All right, hi, my name's Adam Arsenault. I'm a developer on the mobile platform team at Hootsuite. If you haven't heard of Hootsuite before, we're a social media marketing platform. We currently have 15 million members, and we're used by about 800 of the top Fortune 1000 companies. I'm going to give you another journey today. Seems like a common theme, but I'm going to talk to you a little bit kind of like of our history of our architecture, our road to microservices. I'm going to talk a little bit about the service graph just so we understand kind of what we're talking about there. Then I'm going to give you a demo, hopefully, of a dashboard tool that we've created that allows you to navigate in real-time microservice graphs. And then I'm going to talk about the API that kind of backs that all up. So Hootsuite was founded in 2008, and we were a giant PHP monolith, and we still are pretty much a giant PHP monolith with microservices underneath it. That's our main product. We have other products which we are combining microservices in sort of a more modern architecture, but we still, like our main product, has PHP layers, and underneath that, lots of microservices. In about 2013, we decided we would try and actually start using microservices. So at the same time, we were experiencing hypergrowth and continuous integration. We were like playing with continuous integration in a pipeline, deploying our main product, and we were trying to add many moving pieces under the covers at the same time, which caused like lots of problems. Today, we have about 30 plus services in production, and things are a little bit more smooth, but we're not perfect. At about the same time, our CTO was really kind of obsessed about Conways Law. Not sure if you guys are aware of it, but really it kind of states that system design is kind of like constrained by your organization design. So at the same time, while we're hiring all these new people, as we're changing our tech stack, we're basically splitting up into teams too. So we're going from this like large monolithic team into all of these other teams that are going to be creating services. So you would have many different people trying to work on a tech stack together, right? You might have a JavaScript developer that's writing a UI that is dependent on some service way under the covers. What happens if cascading failures happen? We have integration tests in a pipeline that are running and sometimes failing. Oh, well, why are they failing, right? We have those types of scenarios. And then we have production type scenarios where we actually just, you know, the dashboard or the main product isn't working, we're getting alerts, but it's really unclear what the alerts are because there's just so many going on. So we're seeing lots of like cascading type failures. Again, yeah, like the biggest two scenarios that I can think of are more in the integration environments and just trying to give visibility to people. When you start to create microservices and you start to like actually cobble all of these things together, our experience was that most people don't really understand all the services that are there, right? They don't understand all the moving pieces. So for them to actually go and like write a piece of code and deploy it into production is much harder than it was in a monolith because they can't debug the way they normally were able to, and they can't do sort of the normal workflow things that they wanted to do. So to us, the biggest problem was just visibility in general. We wanted to find a way, like how can we empower everybody on the team to be on an equal foot and just say like, you know, something's gone wrong. How can you yourself go and investigate what's wrong? And how can you learn about the system? And how can you empower yourself and your team? So really, our biggest problem was just the visibility and the fact that our architecture is changing all the time. That's one of the awesome things about microservices is that it can just change every day, right? People can push new services, but it's also really hard to understand. So let's just talk about the service graph kind of just in general right now so that we all kind of can understand where we're going with the rest of this journey. So we got a monolith, right? It's really a service graph with just one node. Generally, when like in our journey, we took this monolith and we started breaking it up. So we took common components like member or in our case, organization, and we started breaking those up into services, right? But that's used a lot in your monolith. So generally, you kind of start with something like this. You start simple. You break out a couple services. That's pretty easy to understand, right? There's only one or two more things that you need to know about. Then you add more. And generally, like I think it's kind of common that most people, when they're breaking out from a monolith, will kind of have one layer of services, not really very many interdependencies yet. But the real confusion comes when you start to do stuff like this. You have a whole bunch of interdependencies and services. And now services health is not just like itself, right? Like it's actually dependent on other things. It can't do its job properly if other services aren't doing their job. And understanding that can get way more complicated, especially when you start going. That's 7 services, right? We're saying 30, right? Like when you get to 30 in production, we're not Netflix, we're not Salesforce, but that's still a lot. It's still hard to understand. So what happens when Service 2 here has a problem, right? It's great. Service 2 is having a problem, but it really means this is the issue, right? We have a bigger problem than just Service 2. And so how do we go to enable other people that don't necessarily know that Service 2 even exists? How do we enable them to understand that their test might be failing because of that problem? That's kind of what we were trying to tackle. This diagram here is an anonymized version of our services. So this is a document that's generated from the API. We actually do this daily. I'll talk a little bit more about that later. So right now I'd like to try and do the demo. Let's see if this works.
Let's debug a failure.
Oh, that's too far in.
Looking at a dashboard for a demo app.
Yeah, he's getting it up there.
That I created called the Skateboard Store.
Can we go back just a little bit?
The Skateboard Store is a web application that is...
Okay, cool. Thanks. Low tech, but great solution.
Let's demo the Voltron app. Right now we're looking at a dashboard for a demo app that I created called the Skateboard Store. The Skateboard Store is a web application that is made up of many microservices. I'm going to go over the UI of the Voltron app itself before we start exploring so we know what we're looking at. The top left, we have a set of breadcrumbs, and the breadcrumbs will show us the path that we've taken as we're traversing the service graph. Below that, we have a metadata section, which shows us things like the name of the node that we're looking at, a description, the owners or maintainers, and some links to documentation, code, logs, and statistics. All of these things can be helpful when you're browsing around, exploring, or trying to debug something. Below that, you have a set of internal dependencies and service dependencies. Internal dependencies are dependencies that this node in the graph owns, and service dependencies are the actual microservices. If we look at each item in the service dependency list, we can see that all of them right now have this little graph icon on the right. The graph icon means that you can actually click on that and navigate or traverse to the next level of the service graph. So if we look up here at the breadcrumbs, we can see that we navigated from localhost 8080, which is the actual demo app itself, to the member service. So let's go back to the Skateboard Store demo app. The last thing that I want to point out is the top bar here. Now this is a history list. If you click on them, you can expand them and see more details. Green means good, so that means that a successful status check was run on the server. Red means that some sort of error happened. And if we look here, we can actually see that it looks like member service wasn't running because we got a connection refused error. You can also see yellow items up here, which are warnings. One thing that I want to point out about the Voltron app itself is it does a heartbeat of the service graph every time you see it flicker. So if we watch here, it'll flash here in a second. There. So that was the back end of the Voltron app actually doing a health check and traversing all of the different nodes in the service graph to come back and paint this picture for you. Let's explore the Skateboard Store app using Voltron. Right now we're looking at the top level Skateboard Store app. As we can see on the left hand side, we have one internal dependency, which is Memcache, and we have a list of service dependencies, which are our microservices. let's try navigating into the member service and see what it's made of. So member service looks like it has one internal dependency, which is a member database that is a MySQL database. And it doesn't look like it has any service dependencies. Let's navigate back to the top. We're at a leaf node there. So the next one is a product catalog service. Let's check that out. So the product catalog service has a database as well. And this time it looks like it's a Mongo database. Looking on the right, it doesn't look like we have any service dependencies either, so we're at a leaf node again. Let's go back up to the top. Next, we have the purchase service. So the purchase service is a little bit more interesting. It has two internal dependencies. One, a circuit breaker to PayPal. And the second being a database, which is a MySQL database for purchases. Go back up to the top. The next one is the reviews and rating service. So the reviews and rating service looks like it also has two internal dependencies. This time it looks like the developers have chosen to break this up into having two databases rather than just one. A ratings database, which is MySQL, and a reviews database, which is also MySQL. Go back to the top because we're at a leaf node again. Lastly, we have the shopping cart service. Let's see what it has. So the shopping cart service has an internal dependency of an Aurora database, and it also has a service dependency on the product catalog service. That kind of makes sense. A shopping cart would probably need to know about products. So let's navigate into that. So now we've done a second level traversal in the graph. And we've ended up at the product catalog service, which is a leaf node again. So we can go back up and back up to the top. Let's debug a failure. So to simulate a failure, I've actually stopped the product catalog service. This will create a cascading failure because the product catalog service is actually used by the shopping cart service as well. If we look along the top, it looks like this has been happening for a little bit because we have some history that's showing red. So let's click on a couple just to see that we have the same issue. Yeah, it looks like here we're seeing that the product catalog service is getting an error because we're getting connection refused. And the shopping cart service is failing because the product catalog service is failing. Also because of connection refused. So let's just look at a couple more of these up here to make sure they're the same. Looks like it. And if we look down below, we can actually see the same thing in the service dependencies. So let's click into the product catalog service to see what's up. So the product's catalog service dashboard doesn't even render because we can't actually connect to the service itself. So it looks like there is something up there. Let's just go and see the shopping cart service though, to see what's up there. So the shopping cart service is showing a failure, but its DB looks healthy. It's green. And if we look in the right, it looks like it's because the product catalog service is not healthy. Looks like it's getting connection refused as well there. Just for fun, let's try and navigate in. And again, we get this connection refused. We can't connect to the service. So let's navigate back up to the top. And I'm going to restart the product catalog service. And then we should see this become healthy again. There you go. The skateboard store is healthy and back to normal. And it's quite nice because we actually do have the status or the health history up here. So we can go and after we've fixed our issue, we can go back and look at a timeline so we can see when the item started and when it failed or finished. Maybe we'll take the very first successful health check again. So we get a nice timeline of how long the service was down for. It looks here like we were down from about 3 minutes.
Okay, cool. Thanks, guys. All right, thanks for dealing with that demo. Yeah, so the Voltron, the idea of the Voltron tool. Hello? Okay, yeah, the idea of the Voltron tool is it just makes it easy for everybody to explore and kind of just check out a service graph in real time and look at the health as well. So I'll just go over a quick how we built it. So the technology is on the front end, we got React and we're using WebSockets. And then at the back end, we have Play and akka. We are using a single app with a status polling actor, so you're actually only getting one sort of polling action going through your graph at a time. And like the previous presentation, you can set it at any sort of like interval you want. I had it at 10 seconds there just for the demo, so you could just kind of see it kind of going faster. And then we spin up an actor in the back end for every single one of the WebSockets, which keeps state compared to the browser, so we can like push state around as the user's moving around. We can subscribe to different paths in the graph. The status poller will then start polling on that and start giving you history. And yeah, the one thing that's nice about the actors is the WebSockets is everybody is in sync. So if you have like 5 or 6 people that are all trying to debug an issue, they'll all be seeing the exact same view at the exact same time. All the reloads will be happening exactly the same to all the consumers. So how do we build this? We decided that we would take a little bit of a different approach, and we wanted to, since we were just trying to solve a microservice problem, we would solve it at the API layer. So what we did is we went and we created a standard API that every microservice would implement, and then we would create a framework so people would really just have to go and kind of like write a check or use a whole bunch of checks that we have in a single repository and just configure it. So it's really kind of like a declarative framework that people use when their service boots up, and then it kind of can answer all these questions. So we talked about the dependency stuff a little bit there, but we really just have 2 types, internal and service, or external we call it. So these are the actual endpoints. So we have an endpoint that tells us about the service, and this kind of is done through introspection, so it will look at all of the status endpoints that you build or configure for your service, and it will return the state of all of those, and then a whole bunch of metadata. Some required fields, but then also we allow you to extend it with a custom data element, so you can actually pass back anything you want. So if you have specific data that you want to see, you can do that. For every status endpoint that you actually register, you also get your own status endpoint. So depending on how you want to monitor this, you can monitor it directly using each one. So the examples over there, we have a service called core service and a database on a service. So those would be exposed dynamically in the status routes. We also have a similar idea as last presentation where we have an aggregate status. And the aggregate status will basically check everything in parallel and then return you an OK, a warning, or a crit. But we also allow you to filter it. So you can do things like you can go and say, I only want to know about the internal dependencies. So am I actually healthy, or am I seeing cascading failures? So then you can say, are my external dependencies healthy? And you can do sort of like smart things there and look to see if you're actually healthy just yourself, if you're seeing cascading failures, or you can just get the whole answer. So you can say like, I just want to see everything, am I okay? So you can kind of make different decisions there. We don't really like actually, with this API, make any sort of assumptions about monitoring. We allow you to kind of like make your own monitoring decisions as you like. But we do say that, you know, for simplicity, it's nice to just use aggregate because then you don't need to change checks in the future, right? You just basically say, okay, well, watch this endpoint, you know, alert me if it's ever wrong. And the output of this should tell you the check that failed and then the error. So this is kind of the magic of the dashboard. We have an endpoint there called traverse, and it will take in a list of service IDs and allow you to start at an entry point. So when we were looking at the demo, we were really like looking at the app, right? And then we were kind of going different levels deep into the app. And we actually just doing that through like a REST endpoint. So we can pass the IDs of the services, and because every service implements this interface, we can then traverse the graph. and you just basically take the IDs off as you're going down. You get down to the end of the traversal, and then you can execute an action. So you can do something. So right now, we just have it that you can do this about endpoint. So we just basically are like saying, okay, you check everything that you have, give me the metadata that you have about yourself, and then we'll expose that at the top layer. And so the Voltron app is really just kind of displaying the result of the traverse, and you're giving it the parameters to traverse. The kind of the cool thing that I like about it is in order to monitor a whole application, you really only need to monitor the top level. So like, we don't actually alert or have our alerts at that level, but from a developer's point of view, it's nice, right? They're like, well, I was trying to work on this application, so I can go and look at it from my point of view. One of the other things that I also think that's important about this is it tests the network pipeline, security groups, load balancers, and everything that your actual application does. So you're not sitting on a host and monitoring that, right? You're actually saying, well, if I was a user, would this work? Yeah, so I'll just go over some brief usage here. So again, we don't really say how you monitor. You can use this, you can use the tool, but obviously that's not going to send you alerts. So in practice, we actually use Sensu, and we use the same sort of endpoints locally to monitor the service. And by default, we try to get people to use aggregate. But if their service gets too complicated, and we have some really complicated services with lots of checks, and things that depend on things that we don't even control that are externally. In those examples, we may want to break down the checks and have different sort of intervals and whatnot on each check and different thresholds. Again, like we saw, you can debug with this, right? So we actually have some widgets that show the overall status of apps, and we can put them in deployment pipelines. So you can see like, oh, the test failed on this run. Oh, was the environment actually okay? So you can go and look at that, and you can kind of like judge, was that a valid test run or not? Should we fix the services and then maybe run the integration tests again? That's kind of something that we do. Also, this is useful. So we have a version of Voltron hosted internally in the dev environment, and the app itself just takes URLs or IPs and basically assumes HTTP. So you can spin up a local service, configure all your status endpoints, and then point a local version of Voltron at your service just to make sure it's working. So that's kind of a nice way to kind of like debug before it goes into staging or production. And again, the explore and learn. This is pretty valuable for new employees that are coming into a really complicated set of microservices and really have no idea what's going on. And document. Let's see if this works. It's not a video, it's just a GIF. But like I showed you that one version before, we actually check our UML. So this is generated by UML, and we actually check this into Git every night, and we publish it to Confluence. So every day, as our service graph is changing, we're documenting our service graph and letting everybody else know in the organization what's there. All of these different polls also have all that metadata that's there. So if you have log links, stat links, dashboards, all of that stuff can be generated and put into Confluence or other types of places for documentation. We're still not doing, like we could get better about this, we're still not generating API docs and doing that kind of stuff. That's still all a manual process. But at least we're documenting this in a way that's like growing like our application is, which I think is a big win. Well, I think that's the last slide anyways. Let me just double check. Yeah, and then open source. So we have started open sourcing this. We've open sourced the API documentation itself. So if you wanted to go and have a language or a framework that implemented this, you could do that. We've open sourced 2 frameworks for Go. So the demo that I showed you was all Go microservices working together. And so we have one for the net HTTP library and one for the Gin framework. So those are both open source now. And we're working on getting the tool kind of open source. So similar stuff, we need to kind of pull out some proprietary information and think of the best way to kind of move that forward. But our goal is to share that with the community. We also have a Scala version and a PHP version, which we haven't kind of got there yet. And I guess one of the other things that I'd like to say about it is that because we just defined the lowest barrier to entry as implementing the API, it doesn't matter what language you do it in, it doesn't matter what sort of microservice framework you use, you just need to implement this API. Cool, thank you. Looks like we got some questions back there. Yeah? Yeah, totally. Good question. I mean, it's the same for status endpoints, right? Like, if you're doing anything that's exposing status about microservices in your service, you're not going to put that into production, right? So we block those endpoints. Yeah. Yeah, back here. Yeah, so that's the declarative part. So the declarative part is we give you a framework which allows you to say, I would like a status endpoint for this status check. And so we have base things like if you want to check an HTTP service, we already have a status check to do that, right? So it's pretty declarative. You don't really need to write a lot of code. But you do things like say, I want it to appear at this route, and this is kind of some information about it. But you don't really need to write it like that much code to do that. And then the introspection part is really the crawling part, right? So when you saw that, that diagram that showed kind of all the nodes and whatnot, once you have your service implementing the API, you can do lots of cool things. You've got an API there. You could write tools that do many different things. You could write a tool that goes and checks to make sure all of the nodes have the right version after a deploy. You could do things like, I don't know, I don't have all the answers, but like for us, the biggest win was just the visibility. No. No, it's not doing that. Yep. Yep. Yeah, so the question is, have we experimented with using more of like a graph visualization in the tool? We have a little bit, and we just haven't gotten to a really great solution there. We found that mostly for most teams, they really want to see their service. So kind of drilling into the dashboard is, I think, our first step. But I think that's a good, it's definitely on our nice to have list, is to be able to have a nice live updating graph view. Any other questions? Oh, yeah, down here?
More of a comment, but I really like the about page. Normally that sort of stuff is hidden in the repo, so you find what it is, you go look it up, find the person. Having it all there as part of the service is great.
Yeah, and so right now that's a JSON file basically that's kind of either packaged with the service during build time or just a JSON file sitting in there. In the Go implementation, it's just a plain JSON file. But you're right, like I think that for people to have a central place to go and learn about that stuff, that's important. And we tried to put it as close to the code as possible, because I think then you'll probably update it more. Yeah. Yeah, in the back over here. So yeah, so you can, the question is, what's a network partition look like? You can have a network partition where, for example, one node in the service isn't available, so one worker. Or you could have a network partition where all of, like, one path to the service is not available. So, like in the skateboard store example, we showed one sort of like cascading failure, right? A network partition would generally show up as some sort of flickering. So if it was going there, and depending on like how, it's either the service isn't there, so it's timing out, and you can't get to it at all. So it's kind of like the connection refused example there. Or it's maybe a subset of the whole service that's having a network partition. And then in that scenario, your load balancer, if it hasn't taken out of the pool yet, you would actually just see some flickering. So it would be an intermittent failure, much like your customer would be seeing, right? You'd see certain things going through and certain things not going through. And those are generally hard to find and fix. Yeah. Yeah, another question?
Is there any alerting tied to the tool?
Not yet. So we kind of, we do our alerting through Sensu, and we use the checks, but it's not tied directly. It would be nice to experiment with sort of doing some stuff similar to the last presentation, where we could like, monitor in one place, kind of make some decisions if certain things are going down, and then alert on things. But we haven't gotten that far yet. We've kind of, we're not there. Oh, down here?
Just wondering if you've hit any circular dependency issues. A is down because B is down, and B is down because A is down.
We have had circular dependencies, and you would think that probably wouldn't happen. But so in that, we generally find them. Like, this is actually a good tool in helping you find these weird circular dependencies that you don't really know that you had. And what we would do in those scenarios is we would manually set it to not traversable. So it would show up on the right side as external, but the API wouldn't actually traverse it. So you wouldn't, in a health check scenario, you wouldn't actually keep going through it. We change, so when you implement a status endpoint, you have to implement 2 checks if you would like something to be traversable. So you implement the check, the aggregate check that says, if I look down one layer, are you healthy? That's called the aggregate check. And then we also make you implement the traversal check. And so if you don't implement the traversal check, you can't traverse. So you can still get the healthy part of it, but you won't actually cause a cycle. Yeah, I'm here.
Can you speak to any adoption issues of this tool on services, or was it pretty easy to integrate and spread throughout all services?
Yeah, we definitely had issues. So the question was, do we have any adoption issues? Because when we actually launched this tool, we had about like 15 microservices maybe in production already, and none of them implemented the interface because it was brand new. So the one thankful thing is that all of those services were actually running in the same framework, so we were able to kind of bootstrap the framework and get it going. There have been other challenges of people not knowing that it's there and maybe not filling it out. So that's kind of one thing. And then other challenges would be when we add new frameworks or we use new languages, we then have to kind of build that base again, right? But once you build the base and you get it there, we're kind of, I think, at a point now where the API is stable. We're not making a lot of changes to it anymore, and it's working pretty good. So we have Go services using it, and we have Scala services using it, and we have our PHP monolith using it as well. Yeah?
Have you considered doing something where the rollout is dependent on the traversal or the testing, such that if you forget to describe your dependencies, you fail very early in the pipeline, you won't even be put into product?
Could do. Yeah, it's definitely an idea. We again, we've kind of kept all of this stuff separate. We don't necessarily make it so that you have to do that. You don't have to be part of the graph. If you want to go in there and you want to cowboy your stuff up and you want to put it in there, you don't need to be there, right? That's one of the kind of values of Hootsuite is the autonomy. So we set best practices. We want people to follow them, and we try and get them to follow them, but sometimes that doesn't happen, right? And so each team, again, is a little bit different, does things a little bit different. I guess another example would be if we make an acquisition and we bring in a new company that might have services and stuff like that. They're obviously not going to be doing it, right? So yeah, there's some stuff there. So we would have to basically get them on board and whatnot. Cool. Any more other questions? Yeah, okay, that's time. Thank you.